All right. Again, a lot of the stuff you've probably already heard of before. I want to talk a little bit about that plate tectonics. So one of the things is on this figure, you can kind of see the blue that's over here in Canada, and this blue right here. I'm not sure what that would be. Sorry, is that England? Okay. As it turns out, these guys were once connected. We can tell that. Similarly, this green here, right here, these guys were once connected, and this is awesome. These guys were once connected. So that's one of the things that actually kind of shows that all of our land masses used to be part of a large land mass we call Pangea, and that's coming up here in a minute. Okay, so one of the things that Alfred Wegener, I think I'm saying that right, a while back when they started making maps of the continents, he actually saw where, oh my goodness, this South America looks like it could nestle in right next to Africa, and here we have North America, and it looks like these guys could all kind of just come together and make one large landmass called Pangea. And turns out he's right. So what I call plate tectonics is going on. Basically, we talked about it being the lithosphere that's floating around on the asthenosphere, right? Kind of the ooey gooey part of the mantle. And this idea that Pangea broke apart into the continents we know today is generally would be called continental drift. So they're related, plate tectonics and continental drift. So this is kind of showing you over time, 200 million years ago, this is what our land masses would have looked, our one kind of big single land mass would look like. And I like this figure from your textbook because you can kind of see what's going to be the continents and what direction they're moving. That's a long time ago, 200 million years ago, but you figure it was what, 4.6 billion years ago when the sun turned on, the Earth, the planets became the entities they basically are. And so anyway, so here we go. This is after 100 million years. Oh, excuse me. This was, 100 million years after that, 100 million years ago. And this is actually present day, what our continents look like. Pretty cool. One of the things that is actually helps us understand what the history of our planet is this idea of, first off, sedimentary rock. So kind of as you going down here, this is the youngest sedimentary rock, and this is the oldest. I say rock, but actually one of the videos I watched recently, it could be any sort of material. In order to take sediments and to turn them into sedimentary rock, I think you need time and pressure. So it could be material like ash from a volcano or something like that. Now, if you can kind of see these arrows, what they're showing you, and this isn't ash from a volcano, this is cooling lava, but what you see here is kind of some down arrows, and then you see some up arrows. And that actually is showing you what we call the reversal in the magnetic poles of the Earth. Right now, north points towards I would say north points kind of towards Greenland, the continent of Greenland, and our south magnetic pole points towards Antarctic. And that hasn't always been the case. And so when you see these up arrow and down arrow switch, that's when the poles have flipped. Okay. Igneous rock, we said, was actually rock that's just kind of what I'd like to say cooled normally or gently. Material from the liquid mantle or liquid rock just cooled on its own. So actually, as the rock cools, it kind of freezes as the liquid rock cools, it kind of freezes in time what that polarity was. Yep. So how many times has it flipped poles? Actually, you're looking at about 22 times as we go back in time over the last 4.5 million, that's with an M, years. So 22 pole reversals. Another thing I want to talk about is related to plate tectonics, and this is the Mid-Atlantic Ridge. So when we talk about plates coming up, the lithosphere plates. The Earth's lithosphere is chunked up into these plates. Plates can do different things. They can spread apart, and we actually call that diverging. Okay, and an important thing that happens I'll put an A for Atlantic, a P for Pacific Ocean over here. A thing that happens in the Atlantic Ocean is we have these diverging plates, and then what's happening is that material's coming up and creating what we call the Mid-Atlantic Ridge. Now, if they're not spreading apart, so this is what we call diverging, then they are coming together, converging. And actually, we used these terms in meteorology, didn't we? Diverging was when a kid threw up after eating a bunch of candy and everybody scatters. Converging is when you throw the candy out in the first place. But plates can also converge, and one of the things that plates can do when they converge are create these trenches. Now, if a plate is, one of them is an ocean plate and one of them is a land plate, it can create these trenches. And I think I'll kind of show you more of that. So diverging plates can create these ridges, and we call that actually sea floor spreading. And I'll kind of show you, this is sea floor, this is kind of trying to show you sea floor spreading. This green right here, yep, this guy right here, okay, that is the newest or the freshest. And then here it gets older as you go out. So this guy, the yellow, is the oldest. So can you kind of see as these would be the plates moving apart and new stuff coming up from the below the crust. I think that's pretty cool. This is showing you the same thing. We can also see, or we can age see how old rocks are by, we can take find out these are old by getting rock cores. I'm trying to do the word old. By drilling, getting rock cores.